Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 2 of weekly contest 475, minimum distance between three equal elements 2, right? So in this problem what we need to do, so in this problem same as part 1, right, which we have solved in this same weekly contest, right, question number 1 of 475. So that was part 1, right? Now we are going to solve part 2, right? So problem statement is same for both the problems. So in this problem also you are given an integer array nums, then a tuple ijk of three distinct indices is good if nums of I is equal to nums of j is equal to nums of k, right? And the distance of a good tuple is absolute value of I minus j indexes, right? J minus k and k minus I, right? And we have to return an integer denoting the minimum possible distance of a good tuple. If no good tuples exist, we have to return -1. Same examples as part 1, right? But only difference here is the constant size, right? So in part 1 constant size is very small, right? So here if you see example number 1, so first we have to check like view tuple is there or not. Yes, view tuple is here, right? Because I'm finding three equal elements, right? So just to calculate the distance among the indexes, right? So 0 to 2, right? Then 0 to 3, there is one distance, calculate this absolute. Then 2 and 3, right? This, right? So if I is here, j is here, k is here, right? Or we are taking a b c like this in the part 1, right? So we have to calculate distance between absolute distance between a minus b, a minus c, and here b minus c. These are nothing but the indexes only, right? So you can say ijk or you can say a b c, right? Like this what we were doing, right? So in part 1 we are running one loop, right? A from 0 to all the elements, then b I'm running from a plus 1 to n, then I was running c from b plus 1 to n, three loops, right? So in that problem, the time complexity was of n cube, right? So in that problem, n was very small, only 100, I think, right? So we were able to pass all the test cases. We were able to pass our solution. But in this case, your n value itself is 10 to the power 5. So 10 to the 5 into 3, here, power 3, right? So we are going to get 10 to the 15. Definitely we will get time limit exceed error, right? So definitely we need to think about some better solution, right? So here what you can do here, these are all the elements, right? We have 0 1 2 3 4 5, right? And here if you notice, I'm just dealing with the indexes only, right? These indexes, right? And these are the elements, right? So definitely map should come to my mind, right? In such case I need a place where for us one element I store all the indexes where it is occurring, right? This is what I want. So this is how map comes to my mind, right? So here if you see 1, so I can say 1 is occurring at 0 1 and 5 like this. Same way 2 I can say it is occurring at 2 4 6. Same way I can say 3 is occurring at 3 like this. Okay, so this is the first thing you need to do, right? So right now just of n time complexity as of now, right? Now after that, once this is done, then what you need to do, then you have to check all these na. So all these here size itself is less than 3, right? So we don't need to check this, we need to check this, and we need to check this. So here I will find the absolute difference, here I will find the absolute difference, and wherever the minimum absolute difference is there, right, the total sum, right, like 2 minus 4 2 minus 6, and here if you see 2 minus 6 and here 4 minus 6, right? So I will do the sum, I will get 8. So this is going to give 8, and this was giving 10, right, as discussed in part 1, right? 0 minus 1 absolute plus 1 minus 5 absolute plus 0 minus 5 absolute, it is equal to 10, right? So we have to return minimum. But here see it's very simple now. First I create the map, I store all these, then I just iterate over my map, and here if these values, right, number of values is greater than 3, right, then we need to check all, right? There may be case when, like, let's suppose 1 is occurring at 0 index, 1 index, 5 index, let's say 6 index, 8 index, 9 index, right? So in that case what we need to do, first we are checking if this size is greater than 3, right, greater than equal to 3, then good tuple is there. Then we have to check 0 1 5, we have to check 1 5 6, we have to check 5 6 8, we have to check 6, 8, 9, right? So after that 8, 9, and after there is nothing, so I don't need to check this, right? I don't need to check this. So here if you see, in this also I'm running one loop, like, oh, right, of three elements. So first my I is here, then my I is here, then my I is here, then my I is here, right? So here in this, let's suppose if we have y number of elements, right? If I have y number of elements, so here my I is running from, if you see, 0 to y minus 2, right? If I have y number of elements, so I am stopping here now. I am stopping here, right? So here it's let's say you can say 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, right? So here total number of elements y is equal to 6, right? So here last time if you see, your I is running for 0, 0, and then next to 1, next to 2, next to 3, next to, right? So here your I is running from 0 to here last element was this, right, at 3. So here if I do y minus 2, so 0 to y minus 2 means 4. So I can say 0 to less than y minus 2, right? This is my loop, right? My loop is running from inside this also I need to run one loop now, if I have multiple, right? So I is running from 0 to y minus 2. I am stopping here because after that I need 3 now always, so that is why. So I can say I should be less than y minus 2 until here I'm running, right? Or I can also write it I plus 2 less than y, right? This is actually what I'm using in code. You can write it like this also. Okay, so this is our logic, that's it, right? Here beautiful itself is not there, then return -1, that's it. Okay, so now you can give it a try with map. I'm moving to the code part. Okay, so here first index map I'm creating, and minimum distance I'm setting it to max value, right? Then I'm going to record positions of each value. So I'm iterating over all the elements in my nums array, right? And here in the map I'm first checking if this particular element is there or not. If it is absent, okay, then we have to create one array list. If it is there, then in that particular array list only add that index, right? So this is what I'm doing here. Then after that, four numbers with at least three occurrences, so I'm just iterating over these values, right? Values, index map dot values, right? If I'm creating one array list, right? So in this side we are just storing the array list only for the map. So if this size is greater than 3, if it is not less than, if it's less than 3, then continue, skip. But if it is greater than 3, then I have to check all the elements, right? Here for 1, if it's agree 1 2 3 4 5 6 at this places, so I need to check this like this. So here I'm writing I is equal to 0, I plus 2 less than position dot size. I already explained here above, right? This thing, why I'm writing here like this. Okay, so this is the only reason, right? Then here I'm writing it like this because here if you see at B I'm using I plus 1, at C I'm using I plus 2, right? So I don't want to go out of bounds, right? So that is why I'm stopping it previously, right? Then I'm calculating the total distance, and then mean distance I'm updating it as this, right? And in the end, if we didn't update any mean distance, right, if it is like this only, right, so in that case we have to return -1. That simply means we don't find any good tuple, right? Otherwise we have to return the mean distance. That's it, right? That's it. So I hope that you guys are able to understand question number 2 of weekly contest 475. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.